So our next speaker is John Aynsley, who's CTO of Doulos. John is also a co-founder at Doulos, where he runs a technical team as well as consulting for customers and delivering training courses and seminars. John spent his entire career working in media, specialising in hardware description and verification languages, in particular VHDL, SystemC, SystemVerilog, and now UVM.
Thanks, Frank. So, hello everybody. So I'm going to give you a view of the verification training market, which means my spin will be a little bit different to everybody else's today, because I'm not going to be talking about tools. I'm going to be talking about people and training. And what I think I can bring is a very different view, a very different perspective, because what we do as a training company cuts across the entire market, companies large and small, all sorts of different sectors, from the folks doing the most extreme cutting-edge SoC design through to one man in the shed doing an FPGA design. So it's that kind of different perspective that I'm going to be bringing. Make up your own mind whether it's interesting or not. So I'll talk about verification training, verification language training, our experience with upskilling for verification, which I think is very significant for all of us. Contrast IC design with FPGA design. Might be interesting now we've got the two tracks, the IC versus the FPGA track in one room today. Incidentally, if you were in the IC track today, the FPGA track was pretty well attended. There was quite a good spread of both folks splitting between IC and verification. And then I'll say a few words about the future. So let's talk about language standards. So this list hasn't changed for donkey's years. There was a time 10 years ago when there were lots of new languages coming along, but it really hasn't changed. It's got kind of tedious now. So we've got VHDL, PSL, Verilog, SystemVerilog, C++, SystemC, Tickle, Perl, blah, blah, blah. I'll give you a crude caricature of where these languages are used in case you don't know, and most of you will. So VHDL has typically used in Europe and in the mil-aero section worldwide. Verilog is used for RTL coding worldwide, particularly in ASIC design. VHDL tends to be used more for FPGA design. SystemVerilog is used universally as a hardware verification language. C++, SystemC, TLM2, used for virtual prototyping, building virtual platforms. The thing that has changed and is changing over the timescale of the last few years is the emergence and growth of SystemVerilog, as we keep hearing today, and I will attest to that. And the thing that's really brought that about is UVM. UVM's really acted as a catalyst to the adoption of SystemVerilog. For various reasons that are pretty well understood, but really it gives companies such as yourselves more confidence in entering the market because there is a standard way of doing things, an ecosystem, a standard way of writing VIP, and so on. So, anecdotally, were you to buy me a beer, I'm not saying you have to, but if anybody wants to, that's fine, I would tell you that the VHDL market is pretty steady. Contrary to what you might hear, VHDL isn't dead. Far from it. And people do sometimes collar me and say, surely there's nobody learning VHDL anymore, is there? Well, really that's not true at all, as we'll see. It does tend to be in the FPGA space. SystemC market is broadly steady. I'll show you some numbers in a minute, and you will see a decline over time. But now pretty much SystemC is alive and well, thank you very much. It's found its own niche, tends to be in the complex SoC space. And the SystemVerilog market broadly is growing and still growing, as you've heard already today. That's our experience as well. Primarily driven by the needs of complex verification, no surprise to anybody, and catalyzed by UVM. So now I'm going to show you some numbers. And so I didn't get in trouble with the Doulos sales folk. I'm not showing you actual sales figures, but I'm going to show you some comparisons between the different languages that we do training on over time. So you'll get a relative sense of how the various languages that people have been buying training in have changed over the last 11 years. So here we go. Starting off with UK and Europe, this is some comparative look at the amount of training that we've been running over the last 11 years. And you'll see VHDL is alive and well, thank you very much. It's pretty stable. It's not particularly going up, it's not particularly going down, it's just bouncing along. We still fill VHDL training classes in Ringwood. It amazes all of us. We've been doing this for 24 years now, and folks still turn up in Ringwood to learn VHDL. Huh. Strange old world, isn't it? System C, there was a big bump back 11 years ago, and now System C settled to a steady state. It was kind of interesting because I was there during all of that period. What happened initially is that there were some rather wild expectations as to what System C was going to do for us all. It was the next big thing back in 2004, and lots of folks were thinking, do we all switch from VHDL and Verilog to System C? And they came on training classes and then figured out they weren't all going to switch from VHDL and Verilog to System C. And so that bubble came to an end, but System C lives on very happily. And Verilog's been fairly stable. You can see that SystemVerilog training has grown proportionately and continues to grow. So that's the big story. So this is UK and Europe. If we hop across the pond to the US and the rest of the world, it's a similar picture, only VHDL is a lot less important. So looking outside the UK and Europe, then VHDL is a much smaller part of the picture. SystemVerilog continues to grow. And remember, this is proportionate. The overall market size has grown substantially over this period of time. This is just looking at relative various relative between the languages. Thinking about SystemVerilog and methodologies, I've just thrown in a picture on the various SystemVerilog verification methodologies. No great surprise. It was AVM back in 2007. Then OVM and VMM for a while, and now almost universally UVM, apart from the red bit at the bottom, which is interesting. It's legacy. There are still companies using OVM, there are still companies using VMM, there are still companies paying good money for OVM and VMM training because that's what they're using on their projects. But new design starts are switching pretty much universally to UVM. Interestingly, coming back to these charts, E was on the chart once upon a time, but it's slipped off the left-hand end now. Not that it isn't. I'm not saying anything about whether E is or isn't the best verification language in the world, but right now it's slipped off the left-hand side of the chart because commercially folks are adopting SystemVerilog, as we know. So we've conducted a number. So by the way, these figures are looking at sample sizes of thousands of people a year, so reasonably significant statistically, sample of our training market. We've conducted some surveys in the context of marketing activity over the last couple of years as well, just looking at what our customers are using as design languages and verification languages. I'll put up some actual numbers. The actual numbers you can take with a pinch of salt. It's certainly a biased sample, completely biased. These particular surveys are somewhat ad hoc, taken in the context of particular marketing activities, but they certainly bear out all the other surveys that you'll hear about and have heard about already today. So when we ask our folks what the main design language is, on the ASIC side, Verilog dominates, then SystemVerilog and VHDL, and this is globally, are in second place some way behind for ASIC and SoC design, and System C down there in the very small numbers. For FPGAs, VHDL dominates as a design language worldwide, then Verilog, and then SystemVerilog and System C down in the small print. If we look at verification languages, again splitting out ASIC from FPGA, on the ASIC side, there's a very clear story here, which is the dominance of SystemVerilog as a verification language on the ASIC side. Now, we can argue the details. I think there's probably some bias in the survey here, but nonetheless still dominant. And on the FPGA side, well, much more of a mixed spread, with some folks claiming to use SystemVerilog for verification, a lot still using VHDL. The one chart I didn't put up said that of those people who think VHDL is a verification language, all of them use VHDL as a design language. Because there is nobody claiming to use VHDL for verification and not using VHDL for design, which is kind of not too surprising, really. Okay, so that's kind of where we're at in terms of language usage. Again, cutting across the full spectrum of people who buy training, what that's worth. Now let me say a little bit about tools, and I've got lots of grey hair up here because my experience in the media industry goes back many, many years. So I can remember the day when each of these tools got introduced, each of these bits of technology got introduced. I remember back in the 1980s working on formal methods amongst other things. You know, so this is kind of 30 years ago. We were trying to figure out how to do formal methods. And I can say, what the tools do today in the formal space exceeded our wildest dreams in terms of capability and technology. The formal technology today is just so mature, so wonderful, so capable. So why aren't we all using it? The obvious kind of answer. And I'll say why in a minute, or what I think why. And the same could be true of a lot of these areas. So each of these tools requires a paradigm shift. And you know that you only make a substantial paradigm shift when there's a compelling reason to do so. When you've got a compelling business reason to adopt a new technology, you will adopt that new technology, whatever the cost may be. If you haven't, you won't. So you need a compelling reason to change. And adopting tools isn't just about whether the tool works or not. The tool or the technology's got to work for you to adopt it. But if you look back historically over each of these technologies, there's something else going on. It's all about how much it disrupts the existing design flow. And it's no good how good a tool is if it's a very significant disruption to the existing design flow. It only gets adopted when there's a compelling reason to adopt it. And many of you in this room have adopted these tools and technologies listed here and others very successfully because you're doing very large complex designs where you have a compelling reason to adopt those tools and technologies. And part of the story, coming back to training, is whether the typical engineer can pick it up in a few weeks. And this is my thought for the day really. I kind of, looking back, all the technologies and tools that have been adopted successfully and repeatedly and broadly have been ones that are easy to learn and use. And if you need to recruit some PhDs and get them working for a tool for 6 months before they can start being effective, it's not to say that there won't be some companies doing that, but there won't be a broad spread of companies doing that. So with that in mind, let's actually have a look at some more anecdotal stories of what we've seen in the training industry over the last 20 years. So first of all, some caveats. All engineers are different. And I always say that the quality of the training experience that we can provide depends above all else on the quality of the engineers who walk into the room at the beginning of the training class, right? Everybody's different, and we know there's a huge difference in productivity between individuals working in any team. But let's take a typical case. Typically, somebody turned up for VHDL or Verilog training, they could come on a week's training class, and we could send them off being project ready. Pretty much. Now, some people are smarter than others, but that was the norm. We could pretty much satisfy everybody's expectations. Then System C came along. With System C, for people to go away at the end of the week being project ready, they had to be pretty hot object-oriented programmers when they turned up. And what's more, when they got to the end of the week, they could use System C as a modelling language, but couldn't write interoperable models. They wanted to write interoperable models. They then got to go on a TLM2 training class, which works very well, incidentally. All of this stuff is great technology. I'm not making a point about the quality or effectiveness of System C or TLM2, because it does the job just fine. But it did mark a change in terms of the amount of skills and education necessary to get to the point where you were really productive. Then comes SystemVerilog. Oh, sigh. People often say, SystemVerilog is great for you guys in a training company because it means you sell lots and lots of training, which is true, we do, but it's significantly harder during a training class to take people to the point where they are really productive and effective, because it's all so jolly complicated. So To learn SystemVerilog, you've got to know Verilog in the first place, then you come on your 5-day SystemVerilog training class, and then you need a lot of practice at the end of that week before you're really productive. And you probably want to go learn UVM as well. So you go on your UVM class, and again, when you've finished, you need a lot of practice. So we're talking typically several months for an engineer to get up to speed with all of this technology. And we have a massive failure and expectations out there in the market. You'd be amazed how many times we get phone calls saying, I've got this team of engineers, they need to learn UVM, I've got 2 days budget. Okay, do they know SystemVerilog? Do they need to? Yeah. And so it goes on. So there is a far more significant upskilling needed than there was 10 years ago, say, and a lot of wrong expectations out there. If you haven't made that step yet, and particularly if you're in the FPGA world, what I would say is there's a very clear solution for you in the verification space. There's a very, very well-trodden path. For better or worse, SystemVerilog and UVM work, they do the job, and they dominate. But there's a very significant learning curve to get there, so don't underestimate it. Our contribution to this at Doulos is Easier UVM, which I've talked about in the past, which is basically a bunch of coding guidelines and a code generator. Go to this URL. So almost final slide, Mike. So what we certainly see is an increasing polarization out there in the big wide world, which often isn't obvious at verification conferences that tend to attract all the supermen, the gurus. I think there's a serious shortage of superheroes out there. If you want to use hot verification techniques, then you need superheroes in your company. There aren't that many out there. And what we see is a huge spread. So the likes of many of the attendees here have specialist verification teams using all of the technology listed here on the left-hand side. In the FPGA space, engineers are typically jacks of all trades. They're occasional FPGA designers, and they write directed tests if you're lucky. The ones who, if you're not lucky, they don't even write directed tests. They just program the chips. And really, there is this massive spread, and it's more far-reaching than you might think. Everybody imagines they're on the extreme left-hand side. If you go into companies who are nominally on the extreme left-hand side of this diagram, and you go into actual projects, you will find actual engineers who are maybe in the middle or even on the right-hand side because they haven't quite caught up with it yet. We all imagine that we're working at, when we talk to managers, when managers come to us to buy training, their teams are always the best. They're always really, really smart guys, and most of the managers imagine their teams are going to be able to shortcut the training process because they only hire the best. Right? It's just, of course, it's not true, right? Actually, 50% of the people are worse than average. So,
present company accepted.
Present company, oh, of course, you're the best. I mean, only the best, obviously, comes to presentations like this. Obviously, it's the way it works. So, what do I see in the future? A fragmentation. It's not going to be one size fits all. There will continue to be a wide spectrum of approaches. The broader market needs simple solutions. It always has, it always will. And legacy demands of projects and the practicalities of projects continue to influence what actually happens. So many times we go into companies and say, what do you do for verification? Oh, we got this bundle of scripts. No, somebody wrote them 5 years ago. They don't work here anymore, but nobody dare rewrite them. And that really isn't the exception. No, it really isn't. That's what happens very, very often across many, many projects. So my prediction for the future, we will see amazing, innovative verification tools and flows as we've seen presented here. And there will be companies doing the big chips designs who will continue to use those things, But we'll also see a lot of good old-fashioned HDL and good old-fashioned software. What happens is companies go where it's practical. If it becomes too expensive to do verification, you stop designing hardware, you do it in software instead. I mean, as a company, we're now spending more and more effort looking at embedded software because we can see where the value is going. You know, to take a complex electronic system, more and more value is going into software for all sorts of reasons. Anyway, that's me coming to a conclusion. If you want to know more about the training we actually deliver, come talk to us.
Excellent. There's an online question actually. And this is based on open source VHDL verification methodology, which I don't think you mentioned. Okay. So the question is OSBMM. So do you have any numbers on LSVMM?
Any numbers?
Yeah.
No, I haven't got any numbers.
Even short answer to that anyway.
Having said that, yeah, people are interested in it, but yeah.
As you say, there's going to be lots of different methodologies coming in. LSVMM is probably 5 length. Any questions for John before we go on? We've got time for one question.
Yeah, John, your numbers showed that Verilog was used massively for SoC design, but that didn't reflect in your training numbers. Is that because people can train a Verilog internally and don't need to use?
Partly it's geographical, and partly it's legacy, and partly it's timing. So some of that usage is in countries you might not reach. Some of it, the folks might have got trained 10 years ago and fell off the bottom of the diagram. Yeah, and some of them now move into SystemVerilog. So I think it's about historical dynamics, really.
It's quite interesting. It's quite to see SystemVerilog in design as well. It's for education.
Yeah, I think we clearly see verification driving the adoption of SystemVerilog, but then it's trickling in for design.
Okay, thank you. Thanks, John.